conic section that we're going to tackle today is the hyperbola. So this is the last conic section that we're going to study, and it kind of looks like two parabolas facing away from each other. So we have some of the same typical characteristics. Each one of them has a focus, so together we have foci or foci. They each have their own vertex, and we still have this center that everything builds from. But we have some new things that show up, and they really show up when we start building one of these or doing construction. But we have these diagonal lines that cut through that are called asymptotes. Okay, and we've got slope of those asymptotes that have to do with the b and the a that come in our equations. We also have some new terminology. We have a transverse axis. This would be the major axis, or sometimes if you think of parabola language, the axis of symmetry. Then we have the conjugate axis, the minor axis. And this would be another line of symmetry for it, but it doesn't cut through the parabola. It just separates the two halves. The other big change with hyperbolas is this calculation. The one calculation that we always have to do that relates to c. Now we go right to Pythagoras, a squared plus b squared equals c squared. A little different than when we did the ellipses where this was a subtraction. Now, hyperbolas can go left and right like this one, or they can go up and down like this one on the bottom. And I know this is really hard to see, but I have my two halves of the hyperbola. I have the focus here and here. I have the center, and I have my two vertices. But what I tried to add to this is I tried to add some of these lengths, this A, this B, and this C. When we talk about the major or the transverse axis, the distance from the center to one of the vertices is your A, and the distance from your center to this other point, and we're going to talk about that when we build one of these, is your B. So it's kind of like in the ellipses. Your major axis is your A, your minor axis is your B. Your transverse axis has your A length, your conjugate axis has your B length. And C, which has always been the distance from the center to the focus. But notice now that it's farther away than the vertex, so that that focus stays inside the hyperbola. And when we have an up and down type of hyperbola, notice that these slopes are A and B flipped over as opposed to B and A up here. Let's start with the horizontal one. So here's the equation for the hyperbola. The only difference between this equation and the ellipse equation is now we have a minus sign. That means this is the bigger number, this is the smaller number, our center is still at the same place. So this particular one, a horizontal one, has x in charge, it has the bigger number. So we're going to change the x coordinate to get my vertices. We're going to change the x coordinate to get the foci. And then I put these in here. And these aren't in a lot of textbooks, but I call them construction points. If you think back to the ellipses, we talked about the minor vertices or the co-vertices. Think of these in the same idea, except they're not part of the graph. They didn't show up on anything we had graphed. And then the asymptotes. For a left-right hyperbola, the asymptotes are b over a for the slope, and here's your point. Here's a graph of a left-right hyperbola, the actual hyperbola right here in black. The vertex is on the parabola or the hyperbola. The focus is inside the curve. The center is between those two halves. If we turn our attention to the vertical one, again, the h and the k are in the same place. H is with x, k is with y. But now our bigger number is underneath the y. That's how we know this is an up-down hyperbola. Center hasn't changed. My vertices, now we're changing the y-coordinate. The foci, we're changing the y-coordinate. Again, that c is calculated. C squared is a squared plus b squared. How I keep them straight with the ellipses, this is plus and that's minus. For the hyperbolas that we're studying today, when this changes to minus, that changes to a plus. Again, we've got our construction points in here. I'll get to those when we do an example of graphing, but that's where the x gets to change. And notice our asymptotes have a over b instead of b over a. And again, here's a picture of it. the two black portions, that's the two halves of the hyperbola. They have a vertex on each of them, a focus inside each of them, the center that's in between. And then here's those asymptotes that kind of cut this in half. We're going to talk about this green box when we do an example. For our first example, we're going to start with a hyperbola that's centered at 0, 0. So I'm going to go ahead and mark that down. We're going to have to find the vertices, the construction points, and the foci. Okay, those are the main parts. I'll add to that the asymptotes to help us with our actual construction. First, let's figure out if x or y is running the show. Here's my biggest number, the positive 64. Over here I've got this 36, and it's also negative. So x is definitely in charge here. So my A is 8, my B is 6. So those are the two numbers I'm going to use for my vertices, my construction points, and to help me calculate my foci. And while I've got those two numbers, let's go ahead and do that calculation off to the side. C squared is now A squared plus B squared. So I'm going to add these two things, and that's going to be my C squared. So that means C is 10. Again, the one calculation we have to do all the time. So now I have everything I need to find my pieces. So my vertices, x is in charge, so I'm going to add and subtract my 8. My foci, x is in charge, so I'm going to add and subtract my 10. Then these construction points that I keep referring to, this is a chance for y to do something. That's where I use my 6 to build those construction points. Now the asymptotes, we don't do a lot with them, but I wanted to at least show them to you. Since we're dealing with horizontal ones, we've got y equals, and we're going to put b over a. So we're going to put 6 over 8, both positive and negative. And I can reduce that to 3/4. So that gives me an idea of what those asymptotes look like. So let's look at this from a graphic point of view. We're centered at 0, 0. And we're supposed to go left and right 8. So I've got these points out here. Those are actually the vertices. They're on my graph. Notice that for my foci, I'm supposed to go left and right 10. That's good because my foci are supposed to be inside my hyperbola. Now let's use these construction points. I'm supposed to go up and down 6. I'm going to put in this rectangle that I've been referring to over and over and over again. Notice how I'm going through my construction points and my vertices to get this rectangle. Because if I connect the diagonals of my rectangle, that's where I get these asymptotes. So now I can use the vertex, go towards the asymptotes, and around the focus, towards the asymptotes, around the focus, and there's my actual hyperbola. None of this stuff in here is part of the hyperbola. If I emphasize this a little bit, these are the parts that we're actually looking for when we have this equation. Now, sometimes they won't give us the equation, they'll give us pieces of the equation. And this one's also centered at 0, 0. So I'm going to start backwards with this one. I'm going to actually start with a graph and see if this helps. It says the vertices are at 0, 4 and 0, negative 4. So I know this is an up-down hyperbola. So I know it's going to look something like this. I said it was centered at 0, 0. I want to put those in so you can kind of see that. But I know it's something like this. I just need to figure out some of those pieces. It also says that my foci are at 5 and negative 5. So I know that this hyperbola points up and down already. I just need to find a few more pieces. The interesting thing about that vertice number is that is my A, And the number that I got out of the foci, that is my c. So I have most of the pieces I need to work with this equation. I know c, 5 squared. I know a, 4 squared. I can solve that for b. So I do my solving to get my b squared. I square root that. It looks like b is 3. I'm going to go left and right 3. These are not on the graph. Those are construction points. So when I go to build my rectangle and connect the diagonals, I now have my asymptotes. I have my vertices, so I can get close to the asymptotes without actually crossing them. Notice that the foci ended up inside the hyperbola just like I wanted. If I need to come up with this equation, I now have my a, so a squared, and I have my b, b squared. The last example I've got for you, I moved the center. So I'm going to start with that piece right here. The center has moved. It's now at 1, -2. I pulled those right out of those parentheses. I noticed that this looks like the bigger number of 25, but remember, we're subtracting. So technically, this could be seen as a -25. 16 is bigger than -25. It's the positive one. So that's the one that's running the show. So this is definitely an up-down hyperbola. Y is in charge. So when I talk about my vertices, I'm going to change my y. When I talk about my foci, I'm going to change my y. My construction points are still where x gets to do something. I'll kind of put those in brackets because they're not part of it, but they help us when we do the graphing. And then my asymptotes. Again, we're dealing with a vertical, so now we're going to go plus and minus, and we're going to put a over b. We've got x minus 1, and then a -2 for the y portion. So I got to figure out some a, some b, some c to help fill in some of these gaps. And let me change colors so you can kind of follow along. I'm going to start with the calculation I said I always have to do. A squared plus b squared equals c squared. So I need to add these two things. This is my a squared. A is 4, a squared is 16. My b is 5, because b squared is 25. So when I add those two things, 25 plus 16, that gives me 41. That's my c squared. So c is the square root of 41. I'm going to go ahead and put that in there. 41 is 6 and a little more. It's not quite 7. That's going to fit in well with what we're talking about. For my y portion, I'm going to go up and down 4. For my construction points, I'm going to go up and down 5. And now I can fill in my slope here as well. I have a slope of positive 4/5 and negative 4/5. So there it is analytically. Now let's get to the graph of this thing. It's centered at 1, -2. So I'm starting down here. And I'm supposed to go up and down 4 to get to the 2 vertices. Those are on my graph. I'm supposed to go left and right 5. Those are actual construction points. They're not on the graph. So if I go ahead and make this rectangle that goes through all those points and connect the diagonals, there's my equations. Those are my two asymptotes. That's the equation I was looking for. So the actual hyperbola sits right here. I use the vertices as starting points. I get close to the asymptotes, but I don't actually cross them. Only thing missing from my graph are the two foci. From that center point, I go 6 and a little more, 6 and a little more, good. The foci ended up inside my hyperbola. That's where they're supposed to be. There's a hyperbola not at 0, 0.